Alright, we're going to look at the Calculus 1500 Related Rates worksheet number 6. It says a funnel in the shape of an inverted cone is 30 centimeters deep and has a diameter across the top of 20 centimeters. Liquid is flowing out of the funnel at a rate of 12 centimeters cubed per second. At what rate is the height of the liquid decreasing at the instant when the liquid in the funnel is 20 centimeters deep? Alright, so let's start back from the beginning. It says a funnel in the shape of an inverted cone is 30 centimeters deep. So we have a funnel in the shape of an inverted cone, and it's 30 centimeters deep. It also says that the diameter across the top is 20 centimeters. Now, it's important to notice that this is the height of the entire funnel, and this is the depth of the diameter of the base of the funnel, or the mouth opening of the funnel. That's important because as we go on, those values will change if you're talking about the liquid in the funnel. It says liquid is falling out of the funnel at a rate of 12 centimeters cubed per second. So let's draw the liquid. We have liquid coming out of the funnel. And that's 12 centimeters cubed per second. Guys, that's a volume. So that is dV over dt. And since it's leaving the funnel, that's a negative rate. That's negative 12 cubic centimeters per second. At what rate is the height of the liquid decreasing? So they're talking about the height of the liquid here. They want us to find dH over dt when the liquid in the funnel is 20 centimeters deep. So when the height equals 20. Now, something you may not be able to see quite yet, and this is very important, is that cones have similar triangles in them too. Just like the last problem with the guy with the shadow, cones have similar triangles in them too. So if you look at this as a right triangle, right here, and then look at the big one as a right triangle, the height and the radius always have a relationship. So if you look, the height of the whole thing is 30 centimeters. The diameter of the whole thing is 20 centimeters, which means that the radius of the whole thing is 10 centimeters. If you notice that the height here is 3 times the radius. The height is 3 times the radius. That multiplicity will hold through the entire funnel. So I'm going to make a proportion just like we did on the last one. R over H equals, the radius is 10 over the height of 30. If we reduce that, R over H equals 1 over 3. So that means that R equals 1/3 times H, or H equals 3R. There's 2 different equations you can have. Now, what did they ask us to find? They asked us to find dH over dt. If they want us to find dH over dt, then when we get to the part of the formula that has an R and an H in it, we want to get rid of the R's, so all we have left will be H's. The formula for the volume of a cone is V equals 1/3 pi R squared times H. Now this right here, the R squared times H, is why we have to worry about getting rid of the R's and the H's. If we keep R and H in there, you're going to have to do a product rule, and I don't want to do a product rule. So let's take the derivative of this after we get rid of either R or H. Now remember that we're looking for dH over dt, so that means we want to get rid of the R's. We found that r equals 1/3 h. So everywhere we see an r, we're going to put 1/3 h. V equals 1/3 pi times 1/3 h squared times h. Let's simplify that before we take the derivative. V equals 1/3 pi times 1/9 h squared times h. 3 times 9 is 27, so V equals 1/27 times pi times h cubed. Now let's take the derivative of this. dV over dt equals 3/27 pi h squared times dH over dt. dV over dt equals 1/9 times pi h squared times dH over dt. They asked us to find dH over dt when the height is 20. So that means we can plug in h equals 20. They also told us that dV over dt is -12. So we get to plug that in as well. So the height is 20 and dV over dt is -12. -12 equals 1/9 pi times 20 squared times dH over dt. Okay, if we divide and reduce that, we find that dH over dt equals -27/100 pi. Now the height was being measured in centimeters and the time was in seconds. So that is centimeters per second.